Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Carolina Bays are found from New York to Florida. The Carolina Bays are shallow elliptical depressions with raised rims oriented toward the Great Lakes, but their shape varies depending on the terrain and the erosive effects of wind and water. In 1930, an aerial survey covering around 500 square miles of coastal plain near Myrtle Beach, South Carolina, was undertaken by Fairchild Aerial Surveys for the Ocean Forest Company. The resultant mosaic of photographs revealed aligned elliptical features that caught the attention of scientists. The largest well-formed Carolina Bay to the far left, called Cotton Patch Bay, is 1,920 meters long or 1.2 miles long. Using optically stimulated luminescence and other dating methods, researchers have estimated that the Carolina Bays formed from 7,000 to 200,000 years before the present. The wide range of dates has given rise to the Aeolian lacustrine hypothesis, which proposes that the bays evolved as a result of intermittent action by wind and water over a long period of time. The Carolina Bays are sandy structures that are easily destroyed by erosion. In the 90 years that have elapsed since the first aerial photographs were taken, many bays have disappeared near Myrtle Beach, South Carolina. Flipping back and forth between these images shows that many bays in the central part of the image are now gone. Some bays have been obliterated by urban development, and others have become less defined from wind and water erosion. The Aeolian lacustrine hypothesis proposes that the Carolina Bays have been forming for 200,000 years by the action of wind and water, but in this image we can see that during the last 90 years, Aeolian and lacustrine processes have caused the disappearance of many bays, and not a single new bay has been created. Cotton Patch Bay has a width of 1,187 meters and a length of 1,865 meters. Most large, well-preserved bays have a mathematically elliptical geometry. The elliptical geometry can be confirmed by overlaying a bay with an ellipse that has the same width-to-length ratio as the bay. The sandy rims are outside the elliptical area. Ellipses are conic sections, and the elliptical geometry of the Carolina Bays can be explained if the bays originated as inclined conical cavities that became shallow elliptical bays by viscous relaxation. Experiments confirm that oblique impacts on a viscous surface produce inclined conical cavities that are elliptical when viewed from above, and the raised rims are outside the elliptical area. Carolina Bays are found on unconsolidated soil all along the eastern seaboard. The state of New York has some Carolina Bays, but they are hard to find because they have been destroyed by erosion and by urban development. LiDAR imaging, a laser ranging technology, makes it possible to detect features that are not visible in aerial or satellite images. This bay measures approximately 800 meters in length and has been completely built over. A grid of streets covers the bay. In spite of the urban encroachment, the elliptical geometry of the bay has been conserved. The bay is oriented toward Lake Huron. The orientation of the Carolina Bays varies by latitude, but they are all oriented toward the Great Lakes. New Jersey has some Carolina Bays approximately 70 kilometers or 43 miles northwest of Atlantic City. The rest of the peninsula is too heavily eroded to preserve bays. The bays in New Jersey vary in length from about 150 to 250 meters in length. They are densely emplaced like a blast of buckshot. The Delmarva Peninsula on the east coast of the United States is divided between Maryland, Delaware, and Virginia. The northern part of the peninsula has many small bays similar to those in New Jersey, but larger bays are also encountered. The bays in Delmarva tend to be more circular than elliptical, but the pattern of the bays still looks like a shotgun blast. The southern part of the Delmarva Peninsula belongs to Virginia. The Carolina Bays along this narrow strip of land are circular. This image near Mapsville, Virginia, shows large bays with diameters of approximately 1.3 kilometers. Delmarva does not have deep sandy soil because 35 million years ago, a meteorite struck the Chesapeake Bay and created a tsunami that washed away the loose surface sand of the Delmarva Peninsula. The shallow depth of unconsolidated material in Delmarva made it impossible to create inclined conical cavities, and this resulted in circular bays. Carolina Bays are also found further inland in Virginia, west of Richmond. The landscape is highly eroded, and the bays are found only on ground that has resisted erosion. A closer look at the bays near Richmond shows that neighborhoods have been built upon them, just like in New York. Continuing south along the Atlantic coast in North Carolina, we encounter some Carolina bays that are really big and have a complicated geological history. Using the geological law of superposition, we can deduce that a bay with a length of 1,500 meters was emplaced first. Next, a bay with a length of 3,200 meters overlaid the back portion of the first bay. Then, a bay with a length of 820 meters was emplaced inside the large bay. After the emplacement of the bays, water eroded the drainage channel toward the southwest. There are some very well-preserved Carolina bays near Bowmore, North Carolina. The dimples that cover the surface are Carolina bays smaller than 200 meters that have been almost obliterated by erosion. A satellite view of the same area shows a patchwork of farmed fields, and just a few Carolina bays can be discerned. LiDAR images are indispensable for the study of the Carolina bays. The Carolina bays first gained attention in South Carolina. This is why they are called Carolina bays. The small bays have been highly degraded by erosion, but large bays are well preserved. Highly degraded Carolina bays completely cover the landscape near Branchville, South Carolina. These bays have poorly defined rims and water channels flow through many bays. The erosion of the bays makes it difficult to see complete ellipses and to count the number of bays. Farming is responsible for much of the erosion. Going further south toward the boundary of South Carolina and Georgia, we find non-elliptical Carolina bays close to the banks of the Savannah River. These are examples of bays that were distorted by the topography of the terrain when they were formed. The color gradient indicates elevations. The orchid color in the center corresponds to an elevation of 58 meters above sea level, and the green color toward the bottom corresponds to an elevation of 43 meters above sea level. All of these bays have a flattened shape toward higher terrain. These distorted bays have an elliptical end and a flattened end. The shape of the bays can be explained by noting that the flattened ends of the ellipses are adjacent to areas of higher elevation, and on sloping ground, the conical impact cavities were deformed during the viscous relaxation stage when the liquefied terrain flowed downhill like a mudslide. The elliptical end can be fitted with an ellipse because only 5 points are necessary to fit an ellipse to an elliptical curve. The experimental model can be used to confirm the mechanism of bay deformation. An elliptical impact cavity is modified when the terrain is inclined. The distortion of the bay is caused by soil flowing downhill after the formation of the conical cavity, but the soil flows faster on the uphill side due to the steeper gradient into the cavity. The resulting structure has an elliptical end and a flattened end similar to the bays near the Savannah River. Georgia has some Carolina bays near the city of Pearson. The bays in Georgia are highly eroded and many have disappeared. The northward orientation of the Georgia bays is different from the northwest orientation of the bays in North Carolina, but they are both oriented toward the Great Lakes. Florida has some large circular bays and some small 100-meter bays near the border with Georgia. It is remarkable that such small bays have been preserved, and is probably due to the way in which the sandy terrain drains. The southern part of Florida does not have any bays. In 2001, elliptical features called rainwater basins with the same geometry as the Carolina bays were found in Nebraska. In 2010, Davies and Gilbride calculated the convergence point of the Carolina bays and Nebraska rainwater basins at Saginaw Bay in Michigan and proposed that an extraterrestrial object impacted at that location to create the bays. The glacier ice impact hypothesis, published in 2017, proposed that a meteorite impact on the Laurentide ice sheet ejected ice boulders. Secondary impacts by the ice boulders liquefied on consolidated ground close to the water table. Oblique impacts of ice boulders on liquefied ground created inclined conical cavities, and viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. Experiments demonstrate that oblique impacts on a viscous surface produce inclined conical cavities with elliptical features. The paper proposed that the saturation bombardment by the glacier ice boulders caused an extinction event within a radius of 1,500 kilometers from the impact point, and water ejected above the atmosphere produced a fog of ice crystals in low Earth orbit that blocked the light of the sun and triggered a global winter coinciding with the Younger Dryas. The origin of the Carolina bays has been a controversial topic for 90 years, and the debate is not over. Many years will pass before scientists reach a consensus about how the bays formed. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.